Okay. Hi, everybody. I'm Steve, and this is API First Applications. I'm going to try. My Portuguese pronunciation is always terrible, but bem-vindos ao webinar. Uh, I guess this is, good webinar, Arthur told me. Um, I'm here today to talk to you about this concept, and it's API First Applications. So I have a bunch of slides. The slides are very simple, and we'll get into a bunch of stuff related on this topic. This is definitely a huge topic, and I can't share everything with you in this one presentation, but this should at least be an overview of the concepts and give you the ability to look into this more and decide if building your application this way is right for you. So when we talk about API first applications, we have to talk about software architecture generally, because a lot of things about building APIs and software in general, but specifically when you're building APIs, is about the architecture that you're building. And so I think that looking at what software architecture is actually about helps understand why API first matters, why people care about it, and the reason that this is becoming a thing that people do and know as a technique for building APIs. So I have a little bit of Greek up here. I don't really speak Greek very well, but I would like to. Architecture as a word comes from Greek. So the first half is archi, which means chief, and tekton, which means builder. And I think that this is sort of very indicative. This is why I really like etymology as a way of looking at words, is that you can sort of see how they've been used for a very, very long time. And I don't know, I've always liked etymology. I think it's interesting. And so architecture is about thinking about the chief way that we build things. What is who is in charge, decides the way that these things are built, what is the way that we should build these things as opposed to other ways of building things. And it's really about how you do the building, not about the building itself, which can mean that it's sort of an abstract topic in many ways. And it's also something that's difficult. Programming is about abstract thinking, but architecture is even more abstract than that in many ways. And so that's what's really important, thinking about the way that we build stuff. And this can matter a lot because the way that you go about building something can determine how good it is. There's also many different ways of building things, and having no plan is the same thing as picking a plan at random. If you just go and you don't give any thought to your architecture, that is also a software architecture. It's just an ad hoc, poorly specified way of going about building architecture. So you can't really escape this idea of software architecture and thinking about how you build stuff. You sort of have to, because even if you don't, you're already doing it just poorly. And this is one of the reasons why I got really interested in APIs. I love this abstract design discussion, but it's also really, really important, specifically with APIs, because APIs are about communication. And so when you're trying to communicate with someone, it's very important that you're clear in the way that you're communicating. And this is kind of funny as well, because, so for example, I'm giving this presentation to you in English, but English may not be your first language. And so we had to think about okay, we're designing this communication between me and you. How do we go about doing that? Well, we're going to pick a platform that we both understand. This platform happens to be English. So you can find architecture in almost everything, and especially APIs, are, because they're about communication and they're pervasive in our lives, not just in software. So I think it's an incredibly interesting topic overall, and why I think it's worth focusing on, which is what API first design is all about. And so I want to be clear that this design that I'm going to be presenting to you today, this API first strategy, is just one option of many. There are tons of valuable ways to build software, and I'm not saying that this way is necessarily the best way in all cases. I do think that it is a really good way of building things most of the time, but I do want to emphasize that there's lots of ways of doing stuff. And so this is just one of the many possible ways of doing things. But there's some things that are here between all of these different ways of doing things, and they kind of provide us with a base language to talk about other stuff. So the first is software architecture is generally really interested in this idea of components. So I put Lego bricks up here on screen. We have these different little pieces and we need to fit them together. If you're building the architecture of a house, your pieces are bricks. If you're building a piece of software, then those components may be modules or packages or whatever your particular language calls them. But when we're building bigger systems, we have to figure out how to take these smaller components and put them together. And lots of different ways that we write software and talk about software and programming paradigms and architecture paradigms are about the different ways in which we can develop components and then put them together. And so with APIs, the interesting part is not the component, it's the glue between the components, the interface. So I put a particularly complicated interface diagram up here because I always think they're kind of funny. This is sort of what we imagine a lot of times when we think about architecture is complicated software diagrams that are showing off all of these different components, and there's like dotted lines and dashed lines and different descriptions. And this is useful sometimes, but I think that a lot of times we make things significantly more complicated than they have to be. But APIs are really about interfaces, so it's not a accident. API is an overloaded term in and of itself. Like APIs are used to talk about software components talking to each other, as well as the way that we're talking about today, which is multiple systems communicating over the web. It's just about the difference in scale. So to some degree, even if you're not building web software and you're doing API stuff, you still are doing API things just on a different scale inside of your own code base. And so this is sort of this particular diagram, which I just found randomly when I was looking for interface diagrams, is like talking about components in the software system. But it's the innocuous problem. Like the interface is the way that your components communicate to each other. It's the cement between the bricks. I guess Lego bricks don't really have cement because they clip into each other. The interface is built into the brick itself, but you get the idea. And this is really important to define these interfaces well, because if the interfaces don't match, then your components don't work together and the whole thing falls apart. So a large part of API design and interface design is about figuring out a way to make an interface flexible enough to satisfy all of your requirements, but is rigid enough you can build something strong on top of it. If you make it too strong, it becomes brittle. An example of this in real-world architecture, something that's kind of a little intense, is that in cities where there's a lot of earthquake activity, like seismic activity, skyscrapers are actually built to be flexible. So instead of them being incredibly rigid, if there's a small earthquake, what happens is the flexibility of the building means that it can wiggle a little bit, which is slightly disconcerting if you're up on the 42nd floor and all of a sudden your building moves a foot to the left or moves a foot to the right. But that's much better than the alternative, which is falling down entirely, right? So there's this balance you need to strike between flexibility and rigidness in your interfaces. And that's where a lot of the work comes down into designing APIs. And also, it's really, really important to think about interfaces in an internal versus external form. I mentioned this a little bit in the sense of like building your software out of components or modules as opposed to the way that we think about web APIs. But this also matters once you start building larger systems because, everything is a distributed system nowadays. It's not just because it's like trendy or anything. Like if you have an application and a database, you have two components and you now have a distributed system. And it just so happens that a lot of those interfaces are internal to your project as opposed to external to your organization, but that's a really important distinction to make. And one of the reasons why this matters is that you can make internal interfaces much more rigid because the fact that they break doesn't matter as much. So when you're in control of all of the clients of your API, you can make decisions that break a lot more often because you can just update them yourself. So, if the way that you talk to your database changes, it's no big deal because your application is the only consumer of that particular interface. But if you have a widely used application that's deployed on the web with millions of users, it's much more hard to make a breaking change because now you have to update millions and millions of things. So this concept of internal interface versus external interface is really, really, really important in API design and deciding where your internal and external interfaces lie. It also matters with API-first applications because a lot of the concept of API-first is about making interfaces that used to be internal, external instead. And I think that's really like where we get to the core of this. I have a couple more slides of that later, though, so I'm going to not say much more about that right now. And so, so I want to reemphasize that, with this kind of general system, there's all kinds of things we can do. We have tons of different options, and they all have pros and cons. There's been a lot of talk about microservices lately in API design, and I know a lot of people that are also very critical of microservices as well. For example, I heard someone say recently in a presentation, like, our code design is horrible in our giant massive application, so instead of having one massive application, let's spread our horrible design all over dozens of components. And so, you can go back and forth as to which way is better and how to do these things. So I want to make sure to note this is not necessarily the best way. I think it's a very, very good way. But as always, it depends. That's sort of the core of engineering. It depends. Okay, I spent 10 slides talking about regular old software architecture stuff, but not a whole lot about API first itself. So what is API first design? I sort of have the slash through here already, but historically speaking, what would happen is you are at a company, you build a product, and the product becomes successful. And then people want to extend the product in some way. So they start asking you for features to be able to build on top of this product. And usually that takes the form of an API, but it doesn't necessarily have to be an API in the traditional sense that we can think about it. It could also be like a COM interface or all sorts of other things. And so what ends up happening is you build the product without any concern for how others might use your thing, and then you try to tack this API layer on top of it. And historically speaking, there's some nice things to this approach, but there's also a lot of bad things. One nice thing about it is that it's much easier to just build a product and not worry about these things. But the disadvantage is that over the long term, you're probably going to need an API anyway because people will extend your product. I'll get into that in a moment. But so it's sort of like building product first means that you're sacrificing the long term for the short term. And so API first design is about the opposite. We're saying let's build our API first and then build our own product on top of that API. And it doesn't necessarily mean that it's always 100% first. It might be at the same time. This can go in small cycles. So for example, it's about the individual components and the order that they're built. So what will happen is you might say, we need this new feature. Let's build this feature API first. So what happens is you develop that particular feature in your API, and then you build the UI on top of that API afterwards. And then you have a second feature, and you say, okay, let's add feature number 2. So you build the API first, and then the product. It's not necessarily like big design your entire API up first. It's just about when you're building these things, what order do they come in, and how harmonious are they with each other. And so that's I think a big thing that people get sort of wrong about API first in many instances is that it's not build your whole API and then build your whole product. And I have a lot of criticisms of Agile and the way that Agile has worked, but one of the nice things about this sort of more Agile style of design is you can do these little cycles and get feedback. So I like building small chunks in both. So you do the back end and the front end, or you build the whole thing and then you go on to the next whole thing, as opposed to building each layer individually. And so even though they might kind of be at the same time, since out of the two, the API always comes first, we call this API first style design. And API first design, like any sort of architectural system or way of building software, any methodology, has some implicit assumptions. And I think as engineers, it's our job to tease apart those assumptions and figure out what matters, if those apply to our use cases. And so here's, I think, the 3 most important parts of API first design. The first one is an assumption that you're going to have an API in the first place. If you never plan on ever having an API for your product, then API first design does not necessarily buy you a whole lot. There's still some benefits to it, but I think that a strong assumption is that you're going to end up with an API someday. And this doesn't mean necessarily someday soon, but that you plan in the future to have an API for your clients. And I'm going to go over each of these 3 in depth, so I won't dive into that too much more, but I think that increasingly this assumption is true. Almost everyone ends up having APIs, and we sort of have a lot of APIs coming on. So it seems good to assume that you're going to have one, leaving your option open at least. The second one is important, and that's quality. So if you're going to bother to have an API, you want that API to be a good API. You don't just want it to be whatever stuff you happen to string together. And so API first has several inbuilt mechanisms to improve the quality of the API that you're building. And this is actually my favorite part of API first design is that you know that it's going to be good due to the way that it's built. I think that it aligns incentives really well. Again, I'll get into that in a minute. And the last one is kind of, it's sort of similar. It's about quality. The difference is that number 2 is about external quality, and this is about internal quality. So promoting better architecture, I believe that API first design in general tends to mean that your internal components are also coded in a way that is better and is of a higher quality. And again, this comes out of the way that you align your incentives, but you can sort of think of 2 and 3 as being duals around this internal-external axis. And so, yeah, so knowing you're going to need it anyway and wanting to make it good are sort of the driving decisions behind API first design. This isn't something we like to talk about. One of the funny things about programmers is that we often use these platitudes that are basically universally good. So it's fun because like saying that API first design makes your software better is kind of in some ways almost meaningless because people aren't willing to admit that sometimes bad architecture is okay. And I think that's actually true. This is especially true in things like startups where the speed that you develop is more important than the quality of your code. And so sometimes it's a good engineering decision to write bad code. And I don't think enough people necessarily are willing to admit that writing bad code can be good sometimes. And so this is, I'm making an argument that this is for when you actually do legitimately need code quality. Like it's not when, you're just saying like this is better for some abstract reason. I think that there's a little bit of discussion around like, like move fast and break things is kind of in this angle in some ways. But, I think that you can still maintain quality while going fast. But there's a lot of times, maybe you're not used to those things, or I guess just what I mean is there are valid times when not having a perfect software design is acceptable. And so I think that's important to think about. But I think that having good design is better than not having it, and I don't think that it drags you down that much. So I'm going to say that you should always do it. But like, I think sometimes, it's okay. Maybe you're working with a bunch of junior developers, and the amount of time it would take to level them up is 2 for what you're trying to build, or maybe you know that in 6 months you're going to rewrite this entire component anyway. I think a lot of people say they're going to do that and don't actually do it, but if you do think you're actually going to do it, then making the first one bad is kind of acceptable. So anyway, brief side note about quality stuff. So let's go through each of these things now in turn and talk about how API first design influences them and like why these matter and how they affect this idea. Because really, like, build your API before your product is kind of like, not that complicated in a certain sense, right? It's a sentence. Anyway, so this implicit assumption that you're going to have an API is sort of at the core of this, I think. And I think that this is justified because this logo is for programmableweb.com. If you've ever seen Programmable Web, it's been nice to see it grow up over the years, but I specifically have been tracking what a lot of people call like the API economy, or all these things related to APIs. When I used to go to conferences 5 or 6 years ago, maybe 7 or 8 years ago, and I talk to people online, there's a lot of skepticism about APIs in general. People would say, are you building an API or not? Today, the conversation is much more around what kind of API are you building? Almost every product has some sort of API, and this is due to a number of different things around the shift in the way that our industry works. I'll go into a couple of those in just a moment, but I think that increasingly people assume that your product will have some way to extend it or to use it to build on top of other things. In some ways, this goes down to the core of what the internet is about, right? We have all these servers all over the world, and they're communicating with each other and building things that are more important. Like the whole is more than the sum of its parts. So I think that people today have sort of an assumption that if you don't have an API yet, that's just because you're in the process of building one, and then almost everything that they use will end up being extensible. I think this especially matters for any sort of product that's targeting businesses as opposed to consumers. Like consumers may not demand your API directly, but they may demand extensions that people will then build on top of your API, which turns it from a business to consumer to a business to business kind of thing. But especially when you're interacting with other businesses, I think that people will assume that they can use your product with other people's products and extend your product. And so even if they don't necessarily always have it as in, it's a feature that's compelling as opposed to your competitors if they don't have such a thing. And if they do have such such a thing, you probably want to keep up with them and have one yourself. So I think in both instances, having an API is preferable to not having one. Another thing that's driving this sort of change in our industry is discussion of platforms. It seems like if you track startup pitches, almost everyone says they're a platform nowadays. And what's funny is that the platform used to be something really strong, but today it's been diluted a lot. Since everyone has an API, almost everyone is a platform. And this is why you'll see constantly, we're a platform that does, X for Y is like a very common startup pitch. And this sort of platform idea is that we build some sort of low-level thing, and then you can build your own higher-level things on top of that. And platforms come in all shapes and sizes across all kinds of different software architectures and stacks and products. But this is something that to have a platform, you have to have an API. It's an implicit part of it. And so as things have grown up, this has become more and more of like a buzzword. I think it may be a little bit tired right now, but it is a thing that a lot of people do and discuss and talk about. And platforms are a big deal. So if you're planning on building a platform, you're going to need an API of some kind. Another reason that people are moving towards APIs is that APIs, if you're building a product and you add an API, that API is in and of itself a separate product. And a separate product means that you can charge money for it separately. So sometimes APIs will take the form of like value add, where you can buy the product regularly, but then if you want to extend it, you can pay more money. This is especially common in the enterprise space. But also just in general, you can tier things like API access. And this isn't really related to design so much as the business, but maybe the basic use of your API is free, but using it very heavily costs money, and vice versa. And so another reason to have more APIs and why people are building them is because it's an easy second product. Maybe easy is a bit too strong, but it's easier than building a whole second product. It's kind of like it's a secondary product more than it's a second product. You don't need to move into a new space. You're not really competing with yourself. I don't know. It's just another way to make money, and people, at least outside of San Francisco, people are always looking for more ways to make more money. In San Francisco, they pretend money doesn't exist, I guess. Investor money is the only money that counts. But more products means more revenue, and that's useful to businesses. And sort of related to this, your users are creative, and you should enable them to do stuff. And this is where APIs come in. So to some degree, this gets down to this idea of the long tail, which Amazon popularized a long time ago. But basically, let's say your company has 20 minutes, but you have 2,000 users. That's 100 times more people that are using your application than are building it. And they have ideas around things that could be done to extend your product. And what a lot of companies that have built themselves on top of APIs have said is that we never dreamed the things that people would come up with and then use our API for. And so this is something that you can work your way into the fabric of your users' lives, and they can take your stuff and extend things. And that's really, really powerful. So this is a business case for needing an API in general. And API first stuff can help you with that. And then sort of related is competition. And I think this is something that people talk about but don't talk about. And that's if you build an API and someone wants to compete with you, they could either develop their entire application and also build an API, or they could just build their product on top of yours. And if they do that, they're not really competing with you directly anymore, or at least not in a way that you care about as much, because they are probably paying you for the privilege of using your API. And so that's really, really compelling when competitors are interested in moving into your space. If you already have an API, then there's less incentive for them to reinvent the wheel. They'll argue with themselves that it's faster for them to build things on top of you than it is to compete with you directly. And so this is another reason why I see CEOs talking about wanting APIs, is because they would rather get a slice of any competition that exists rather than force them to build things totally separate. And the last reason that I'm going to have an API is sort of a good thing in terms of API first design is that it's easier to start with this assumption. So this kind of leads into the quality things that I'm going to start talking about, the other 2 points. But you can build a better architecture if you know all the requirements of the things that you're trying to build. One of the hardest parts about building software is when requirements drastically change. And so if you are not sure if you're going to have an API or not, or if you want it to be public or not, it's easier to start with an assumption that you're going to have one and build in an API first way, because if you ever do decide to expose an API later, you've done a whole lot of the work that's gone into building that API already, and you're much better positioned to deliver an API with high quality than you are if you started the day that you decide to fully commit to the API. And so, with this internal-external thing I was talking about before, if you're on the fence, you could build in an API first way, but not expose that API publicly, just keep it internal as a private API. And then when you decide to commit to it finally, you just flip the switch, and now you have a full API already built. Whereas in the other direction, when you build the product first and the API on top, the day you decide, okay, we do want to commit to having an API that's public, you're going to have to start building a lot of software, and that's going to then lead to it taking a while to ship and you doing all that work and things like that. And so it's much easier just to be able to turn it on at any time that you're actually comfortable. So I think that's why this is like the core assumption about building API first applications. Design is fundamentally about trade-offs, and knowing these assumptions is really helpful. This is, I would say, probably my most commonly repeated bit of advice is that engineering is all about trade-offs, and knowing those trade-offs makes you be able to decide which one of those trade-offs matter for you. And this is broadly applicable across all of software, not just APIs. Okay, so enough about the business case of APIs doing stuff this way. The second assumption is this external quality. So I need to make my external interface good. If I'm going to ship an API, then I want it to be of high quality. And I think that the number one driver of this quality is building things API first. And the reason for that is dog fooding. I love the term dog fooding, first of all, because it's very evocative, and secondly, because it gives me an excuse to put photos of dogs in my presentations. This is this first dog. Don't worry, there are more dogs coming. The important part about this concept of dog fooding, so this is actually from Microsoft. They were the first to popularize this notion. Basically, the idea of dog fooding is that you eat your own dog food. And sort of what that means is, dog food is not food for humans, so it might be a little gross and disgusting, but you can also eat it, it is food. So if you practice eating your own dog food, then you'll make the food better because you have to eat it. And so the idea here is that if I have a pet and I never try his food, I don't know if I'm giving the pet good food or not because I've never tasted it, and there's no feedback loop for which I can decide if that food is of high quality or not. I kind of have to pay attention to secondary characteristics like whether my dog looks happy or not. Is my dog doing this? If my dog's doing this, then he wants more food or she wants more food, and then I can know that my quality. But if I'm eating it directly, the feedback loop is much, much shorter. And also it's hard to tell if a dog likes something or not because dogs are always cute, so you can't tell if it's good or bad. But this is sort of the idea, is that you decrease this feedback loop, and since you're consuming your own API to build your product, you can know whether or not it's good because you are using the API. You won't find out that, maybe, so I've worked at places where they build an API second, and one of the problems with that approach is that you'll find out from one of your customers later, oh yeah, this one part of the API isn't very good, it doesn't suit our needs very well, and then you're like, wow, why didn't I ever know this? And it's well, because you forgot about it. Maybe it was the first part that you built and you weren't as good at it, or for various other reasons. And so if you eat your own dog food, you can guarantee that it's delicious. And unfortunately, this is the last dog photo, but there we go. So this aspect of eating your own dog food is, I don't know, it's great. It's why I like building APIs, because then you can try them out yourself. And this gets back to a repeated thing that's repeated throughout this presentation. Design is about trade-offs, and knowing your assumptions help. If you are using your own API, then you will know whether or not it's good enough to build the kind of products that you're trying to build. And so this will help you make your design better because your own pain will force you to make things of higher quality, and it will help you to improve points that are painful and make them better. So I think the dog fooding is the biggest part about external quality with API first design. And then promoting better architecture. So this is the internal quality of your application as opposed to the external quality. And this is something that a lot of software methodologies are really concerned about. Thousands of pages of ink have been spilled on how to make your software better in terms of, software architecture internally. So how does API first design help us here? Well, the first one, and I think the most important thing, is that it allows us to clearly separate our concerns. And so what I mean by this is that when you have one big giant application that's doing everything, it's really, really easy to make a mess. And the reason it's easy to make a mess is because you can take lots of shortcuts, because there's no clear delineation between the different parts of your application. This is why we've seen a move towards microservices and a move towards more and more things of smaller size, is because whenever you split up one giant thing into many small things, you now have a clear separation between those components. And once you have that separation, then you can start talking about the interface and how to actually make those interfaces good. When you're building an API first, you're assuming that you have an interface already in the way that you're building. And this means that you already start off with this separation of concerns. It's not necessarily let's build a monolith and then break it into a ton of small microservices. It's kind of unrelated, but it's in the more sense of like my front end and my back end are clearly separated, and there's an API that communicates between them. And I think that that's a really big thing that can start you down the road towards quality. And when you start separating things, there's questions about whether or not you should separate things in other ways. It really just depends in many cases. So separate concerns and separate code bases, I think, works really well. And this is one of the reasons why I like API first design, is that your API consumer and your API producer have totally separate code bases because they communicate with each other over HTTP or some other format. And so I think that these two things are definitely separate. And so it's nice to have them in separate code bases. Once you have separate code bases, your inclination might be to put separate teams on each of these code bases. I made this smaller and put a question mark here because I think that this can be valuable, but there's also a lot to be said about cross-functional teams that are able to work on multiple code bases at the same time. So I guess what I'll say is, as you scale, you might find that if you have 50 employees and you put 25 of them on the front end and 25 of them on the back end, okay, then you have separate teams because you have so many people. But while you're small, I don't think that it's necessarily useful to completely separate your teams from those code bases, and allowing anyone to fix the front end or the back end or any various part of your application is a much better way of going. At least in the design scene. Once you start splitting up teams, you have overhead between those teams, and that can slow you down. So you don't want to do it too early, but you don't want to do it too late either necessarily, or maybe you do. It just depends. I guess what I mean is splitting up the code, I think, is a clear win. Splitting up the people, I'm not entirely sure is always a clear win. It could go either way. I sort of alluded this earlier when talking about microservices. I'm not always sold on microservices. That might be too fine of a granularity, but I think that in general, smaller components are easier to understand. And so having a lot of small components is easier to understand than having one huge component. And this is because it allows you to understand just one chunk individually before you move on to the next chunk. And when you have these separate things, it's much easier to look at each piece in isolation because you've already thought about the ways that you're doing that isolation. Again, I don't necessarily mean 100 microservices. I just mean this difference between the API producer and the API consumer that you now have when you do things API first means that you can pay attention to only one half of that equation, and that means you have 50% less things to think about, or depending on how you slice it, obviously it's not always 50%, but you could pay attention to less than 100% because you can focus on just one side of that divide. And I think that's very useful in terms of understanding and promoting software quality, because a lot of software quality really boils down to confusion and understanding. It's not necessarily things like lines of code or cyclomatic complexity or these other things around quality are secondary to the point, which is I want to be able to understand my code. And so I think API first design really helps you understand your code because it promotes this separation of concerns. And again, design's about trade-offs. Knowing your assumptions helps. I think that this split really helps you understand what's going on. I won't belabor myself again. I've already done it twice. Okay, so those are the 3 big points of API design and sort of how they play into each other. I think that now is a really wonderful time to start playing around with these ideas because we're sort of in this golden age of APIs right now. There are so many resources on how to do this. If you'd been trying to build an API, let's say like 10 years ago in 2005, there would be almost nothing. Like it was totally the Wild West. People weren't even really sure how to use HTTP properly in those days. And there was many arguments and discussions about like how you should be using HTTP. And of course, there's still arguments and discussions about those today, but I'll say that we as an industry have moved forward a lot more. And there's at very least resources that can help you understand those things if you don't know already. So the amount of books and tutorials and conference talks and other assistance there are for building APIs has never been greater. And in the last 5 years, I would say that I've seen it blowing up at an exponential rate. So that's really fantastic for getting started. And if you want to be able to build APIs, build an API-first application, there's more and more people talking about doing this and being able to help you. So I'm going to go over a couple of tools that I use. The first one is the specification that I work on called JSON API. I've given a lot of conference talks about it, so I'm not going to go into it in too much detail. But basically, if you've never built an API before, you don't know how to build an API, JSON API is a specification to explain how to do various regular API tasks. And I think that it can really help you if you've never built APIs before and you need some assistance there. Another great reason is that following standards gives you shared tooling. So there's a whole lot of libraries that can help generate your API from this kind of thing. And so I think that it's really fantastic, and building these standards is really useful. In terms of that tooling, there's this project called Endpoints. And one of the things I love about Endpoints is that they use the spec as their example on the homepage. So that's some JSON API JSON. But it is a framework for Node.js that lets you build APIs specifically using the specification. And it's really, really suited for API-first design. Basically, the way that Endpoints works is you declare the models that you want and the data that goes in them, and then you point it, you configure it with like a Postgres instance, and you set it up with your Node stuff, and then you just have a full API. Like it generates all of the CRUD stuff that you need, and it generates all of the things related to the specs. You can do filtering and sorting and searching and included resources and side loading things and all these things. And it's really easy to get going with, and I think that it's a fantastic example. Even if Endpoints is not necessarily like the framework for doing API first stuff, I think that frameworks in a similar vein are very, very useful, because one of the things that happens when you build things API first is more and more of your logic moves into the client, and I'll get to that in a moment. But it means that our servers have a little bit less going on, which means they're much simpler to understand. And I think that we'll have this next generation of web frameworks that are simpler on the server because they know that you're going to be using them as just an API. So previous frameworks like Ruby on Rails, which I love dearly and worked on for many years, assumed that you were going to have this monolithic application. And so they did a lot of work on like figuring out how to make that really customizable. But I think you can get really far really, really fast with a spec and a framework like Endpoints. And I also don't want to say that JSON API and Endpoints are the only way to do this. If you want to build your own API totally custom yourself, that's totally fine, and that's what most people do. However, there's an increasing number of that you can use, like HAL or collection.json or Siren, and these are all formats that help you understand how to build your API and give you recommendations for how to build it. So if you don't like my specification, there are many to choose from. That's the wonderful thing about specifications and standards, is there's always multiple standards. But I think that these things really help when you're building things API first, because really you want to build your application, and the API is to some degree a little secondary, or maybe you don't have as much expertise, and so I think that this help is helpful. And as part of that too, another reason that I think we've seen a rise in API first design is single page applications. And single page applications for a wonderful build things API first. And that's because you sort of kind of almost do it by accident when you're building an API in this way, or when you're building a product in this way. Because if you're using a lot of JavaScript on the client, you need that JavaScript to get its data from somewhere. So it makes some kind of request to your server from the client to make your stuff happen. And so that is an API. So you end up kind of building an API whenever you're building a single page JavaScript app. And so I think that going API first can be really, really useful in doing this. And I think that the rise of the single page application architecture is also what's driving a little bit of this API first architecture and sort of driving why people are building applications that have APIs, because you just need one to be able to do this in general. I myself have a side project that I've been working on. I haven't committed in a little bit as I've been kind of busy, but by the end of the year, I'm wanting to work on this. So I'm building a little CRM for tattoo shops. It's called Artisan Assistant, and it is built in this particular style, API first with a single page application. So if you go on GitHub, you can check out its code. One of the things that's difficult when giving presentations is providing examples that are complicated enough to be real, but not so complicated that they're hard to understand. And so this is basically just a little content management system for customer data. If you're running a tattoo shop, or really it's applicable to any kind of shop, but we're working on tattoos because I know a guy who wants to use this. And so I think that it's relatively small at this point, and so it can be useful for you to check out how this kind of thing feels. You can see that the API is just a fully complete API using said endpoints, and then front end is an Ember application that speaks to that API. And so when I was actually building this application, I tended to work on the API first. So we'd say okay, what modules do we need? What kind of data are we storing? And build this API, and then on top of it, add the Ember thing later. So you build out the feature of, okay, we need appointments. Then make an appointment resource, and then make the API serve up those appointments. And then we would move to the Ember side and say, okay, now how do we make those appointments appear in the UI? So I think that this style works really well, and I'm not just preaching this, I guess. I'm saying I'm also building things in this style. And so you can check out my little product efforts in this example, this repo. And I do happen to think, like I said, I use to show you the tools that I'm using Ember. Ember works with JSON API really, really well, and I really, really like Ember a lot. There are other JavaScript frameworks that you can use, of course, to do this as well. However, I think that Ember is a great example. If you've never used one before, I would highly encourage you to check it out. So with that, apparently when I exported this to PDF, the emoji hearts did not actually display. So those boxes should be emoji hearts. But I wanted to thank you guys for having me here today to tell you a little bit about API stuff and why API first might be a good way of building your application. So it's not too complicated. All you have to do is build your API, then build your product. Build your API, then build your product in that cycle instead of tacking APIs on later. So I have another little thing that Artur wanted me to say, so hopefully I can say this right. Obrigado por ter assistido para mais webinars. Acesse mundoapi.com.br. So I know obrigado is thank you, so that's definitely what I wanted to say. So thank you so much for having me.